Hello, I am Lowie Degrave and I'm going to be talking about GUIDANCE2. So GUIDANCE2 is an algorithm for multiple sequence alignments that takes into account the regions with a high uncertainty. So here you can find the links to the tool and the article that I'm about to use. But before we get into that, let's take a look at the index. So first off, I'm going to talk a little bit about multiple sequence alignments and what problems there are with basic multiple sequence alignments. Next off, I'm going to explain GUIDANCE2, how it works, and how you have to use it. And last of all, I will talk about the article that I chose. But first, multiple sequence alignments. So this is a technique that is essential for comparative analysis of both proteins and nucleotide sequences. Over the last years, the accuracy of multiple sequence alignments has risen, but there is still a substantial amount of errors in these alignments. These are called uncertainties. It is important that the uncertainties are removed from the sequence. If there are uncertainties upstream, it is important that they are removed before analyzing regions downstream. Otherwise, these errors will influence further analysis, such as the detection of positive selection or likelihood-based tests which are needed for creating phylogenetic trees. That is why new multiple sequence alignment algorithms are created that give a higher certainty value. One of these algorithms is GUIDANCE2. So GUIDANCE2 will weigh, filter, or mask aligned regions that are unreliable before additional analysis is performed. So right here you can see a scheme of how GUIDANCE2 works. So the input for this tool can either be DNA, RNA, or protein sequences. The sequences should be in FASTA format only, and these sequences will then be aligned using either ClustalW, MAFFT, or PRANK. It is also possible to use a multiple sequence alignment as inputs. So as you can see here on this scheme, the first step, we have the input multiple sequence alignment. This input multiple sequence alignment will then be used to create neighbor joining bootstrap trees, as can be seen here. So these trees, there are a lot of multiple alternative trees that can be created based on distances. So GUIDANCE2 will then use these bootstrap trees as guide trees to realign the input multiple sequence alignments. So it will use ClustalW, MAFFT, or PRANK again to align these multiple sequence alignments with this one. So the tool will look for regions that are uncertain, and the tool will mark it. And based on the level of uncertainty, a guidance score is given to the alignment. A low guidance score means that there are a lot of uncertain regions in the alignment. To decrease the number of alignment errors, a guidance cutoff can be indicated. All residues with scores lower than the cutoff are replaced with N for nucleotides or X for amino acids. Now let's take a look at the web page of the tool. So at the top of the page you can find a text box. Here you can paste your FASTA formats, or you can choose, you can search for your FASTA file in your files. It is recommended that if you use large strings that you upload it as a file, because otherwise it will give an error. So next off we have to choose the sequence type. So we have amino acids, nucleotides of codons. So I'm using the abcd.fasta, which are amino acids. So I have selected this. Next off, we will select the MSA algorithm. So we can choose between MAFFT, PRANK, or ClustalW. We will choose a default, which is MAFFT. This one is the fastest. Prank is significantly more time consuming, so we won't take that. If you want, you can enter your email address here so that the results will be sent to your inbox. You can also choose a job title. So I've chosen guidance test here, and you can enter the CAPTCHA. We also have some advanced options. We can specify the number of bootstraps repeats. So the default number here is 100. The higher this number is, the more accurate the confidence score will be, but it will increase the running time. The output orders can also be changed because some multiple sequence alignments will change the order of the input. So if you want the same as input, you can just select this option, but we'll just leave it as default. And next off, you have some more advanced options, but these are only for advanced users, so we'll also leave that at default. And now we can press submit. So right now we can see that our job has been queued. We can also see the parameters which we have given in. So we just have to wait until this changes to running. So right now our job is running and we can see the running progress. So these are the 4 steps that it needs to do in order to complete our job. So this might take a while, so I'll cut right to the results. So these are the results for our guidance tests. So as we can see here, we have our guidance alignment score, which is around 0.80, which is not bad, but also not great. Next off, we can see our output files. So these are all output files, which contain our MSA, multiple sequence alignments, and which contain our individual alignment scores for each column, each sequence, each residue, and each residue pair. And next up, we have some additional options that we can select. So let's take a look at the multiple sequence alignments file. So this is just a regular multiple sequence alignment. This is the input sequences that have now been aligned. Next up, we have the guidance column score. So for each column, there has been given a guidance score. So as you can see here in the beginning, they are very low, but as we get further, we can see that they start to increase. So here we have a couple of perfect scores. So this is the guidance score for each column. We can also see them for each sequence. So for this is per sequence that we can see our guidance score. So next off, we can see our cutoff. So here we can select a certain cutoff and it will mask all the residues that are below this cutoff point. So for example, if we choose a cutoff of 0.5, that means that 87.4% of the residues will remain. So if we select that and click mask residues, we get this result here. So these are all our regions which have a guidance score below 0.5. So these amino acids have been replaced with X's, as you can see. Next off, we can also remove unreliable columns. So this is the same principle. So we choose a certain cutoff. So let's say 0.5 again. And 79.44% of the columns will remain. So let's remove our columns. So here we can see that instead of replacing the amino acids with a guidance score below the cutoff, they just removed them altogether. So there are no more X's visible. So all the amino acids with a low guidance score have been removed. And last but not least, we have the option to remove unreliable sequences below a certain confidence score. So here we have less options simply because there are less sequences. We only have 10 sequences. So let's say we want a cutoff of 0.806. So let's click remove sequences. So here we can see the results. So these are all the sequences that have a guidance score above 0.806. So these are just the input formats, as you can see. So they are not alignments, but they have been filtered out. So this is the result of our guidance 2. So now that we know how the tool works, I'm going to be talking a little bit more about the article. So the article that I chose was Guidance 2, Accurate Detection of Unreliable Alignment Regions Accounting for the Uncertainty of Multiple Parameters. So this article explores different multiple sequence algorithms and their possibility to detect uncertainties. So the first test is a test with high error rate algorithms. These include T-Coffee, Prank, MAFFT, and ClustalW. The next test is with low error rates algorithms. So these are Guidance 2, Guidance, HOT, Zoro, TCS, AliScore, Trim AI, and Noisy. For these tests, they use both empirical benchmarks and simulated data. Each algorithm is used to align these benchmarks, and the column results are then compared to determine the reliability. For empirical benchmarks, we use Homstrad and Bali-Base. For simulated data, we use Indelible and Orthomam. So, Table 1 shows us the percentage of correct alignments for each high error rate algorithm. Both benchmarks show a low alignment performance. These results are too low for us to use for further analysis. For the low error rate algorithms, we can see that Guidance 2 shows us the best performance on both benchmarks. This suggests that Guidance 2 can accurately detect erroneously aligned columns. We can also include that Guidance, HOT, Zoro, TCS, and AliScore also have good performances. So the conclusion that we can make is that Guidance 2 is a tool that is able to detect regions with low reliability in our sequence. It has a good accuracy, and it can be used to remove these regions from our alignments so that we can use these multiple sequence alignments for further analysis. Thank you for your attention.